Namaskara students, welcome to vkarnataka, KCET and Boards. I'm Diksha, your chemistry master teacher. So everybody, now we are going to do fixed questions for your chemistry PU board exams, right? But before that, let me know in the comment section if I am clearly visible to you and audible to you. Everybody, if I am clearly visible and audible to you, then let me know in the comment section so that we can start with this session, right? And so many of you were asking, ma'am, numericals. So don't worry, right? I'm going to take up numerical in this particular session, right? Don't worry about that. All the important numericals or the important formulas I'm going to take up here, right? Okay. Yes, ma'am. Should I start? Very good, very good, very good. But before that, let me see how many of you have actually liked the session, right? 87 students are watching. I want at least 87 likes on this video, right, on this live session, so that all the students who are attending are also liking the session and also subscribing to this channel so that you can also get notified for the further lectures that we are going to take for PU board exams, right? Okay. Yes. Yes. Okay. Organic chemistry marathon students, we have already taken up. That was yesterday. So you can go and check that out. Right? Okay. Now, let us see the first question on your screen, that is from solution chapters. So from solution chapters, the numerical that is most important, definitely they will ask you one numerical from colligative property, that is sure they are going to ask that, right? So one of the examples of the kind of numericals that they will ask you is on dissolving 2.34 gram of solute. Now, here remember that whenever we are talking about solute, I am representing it by 2, okay? And solvent, we are going to represent it by 1, right? So, here they have given on dissolving this much amount of solute. That means we are provided with the weight of the solute, that is W2, right? In 40 gram of benzene. So, this much solute is dissolved in some particular amount of solvent, right? So, solvent is represented by 1. So, this is going to be W1, right? Now, we don't have any idea about the solute, but we know that what is benzene, that is C6H6. So, from that, we can easily calculate the value of M1. That is the molar mass of benzene. We can easily calculate, right? Now, the boiling point of the solution was higher. That means this question is from which colligative property? This question is from elevation in the boiling point. From that colligative property this is from, right? The boiling point of the solution was higher than that of pure benzene by this much. That means they have given us the difference, the boiling point with the pure solvent and the difference from boiling point when it was a mixture, right? That means they have given us delta TB. Now, Kb is given to us, Kb is also given to us. They are asking you calculate the molar mass of the solute. So, simple formula here is delta TB equals to molality multiplied by Kb. Now, what is molality? Molality is number of moles of solute, that is weight of solute divided by molar mass of solute multiplied by number of moles of solute divided by the weight of solvent, that is W1, and this is 1000. If all of this is in grams, this will be in 1000, right? Now, if you see this particular formula, you have the value of Kb, you have the value of W2, you have the value of W1, you have the value of delta TB. So, you can easily calculate the value of molar mass of solute from here. Is that clear to everyone? Is that clear? So, a simple question based on colligative property will be definitely there in your exam, right? Whatever I am telling you, you will see in your exam, that I can guarantee, right? Okay. So, easily you can do the calculation here and solve it 128.72, right, directly. Now, in subjective questions, right, so what is the benefit even if you leave, even if you, let's say you have just 2 minutes, right, and examiner is going to take away the sheet from you. Now, ma'am, what to do? Don't stress about solving, right? the examiner will at least give you, if this is a 3 marks question, they will at least give you 1.5 marks or 2 marks, right? But if you have time, solve it till the end so that you get full marks here, right? Because in these kind of questions, which are not theory based question, they are numerical based question, definitely you have chances of getting full marks here, right? If you answer it correctly, right? Next question is from electrochemistry. Now, from electrochemistry, two major important numericals are, first numerical is directly based on the Nernst equation. Directly apply the Nernst equation, and now I'll tell you how to apply the Nernst equation, right? Now, the question that is given to us is calculate the EMF of the cell in which following reaction takes place, right? So, this reaction is given to us. Now, if you talk about the Nernst equation, that is E cell equals to E naught cell minus of 0.059 divided by n factor log of QC, or you can say log of product by reactants. You can directly write log of QC, right? Now here E naught value is given to you. This is already given to you. They are asking you the value of E cell here. That means you have to find the value of N and QC here, right? What is N? N is the number of electron lost or gained. If you see this here, this is going from 0 to +2. That means 2 electrons are getting lost here, right? So here you are gaining 2 electrons. 2 multiplied by 1, this is +2. This is 0. 2 electrons you are gaining here, right? So that means N factor is going to be 2, right? This you already know, right? What is log of QC? What is log of QC? Anybody? That is product by reactants, right? Now here, what is the product? As you can see, this is in 15, 18, 20, right? Repeatedly, they are asking you this question, right? Log of product by reactant. So this is the product, this is the reactant part. So it is going to be log of nickel 2 positive, right? There is no stoichiometry, divided by Ag positive raised to power square, right? Because here the stoichiometry is 2. That's why that will be raised to power 2. So that is going to be the overall answer. Nickel 2 positive is given to be 0.16 and here it is given to be 0.002. You just put the values and eventually you will get the answer here, right? Okay, just put the values, you will get your answer here. That's it, right? Okay, is there any problem over here? Once you solve this, that will be 40,000. You can also write it as 4 into 10 raised to power 4, right? Log of, I'll just solve it for you. This can be regarded as 4 into 10 raised to power 4, right? You can also write it as log of 4 plus log of 10 raised to power 4. You can also write it as 4 of log 10, right? Log of 4, you can write log of 2 of log 2 plus 4. Log 10 is 1. So this can be your final answer when you solve this particular statement here, right? Okay. Is there any problem? Is there any problem till here? Students, are you able to understand how to solve the value of log of 10, 40,000? Right? 4 multiplied by 1, 2, 3, 4, 10 raised to power 4. When it is log of this multiplied by this, that can be added here. Log of 4 plus 4 of log 10. Why? Because log of 10 raised to power 4, this will come to the front side and this will become log of 4 of log 10. Right? After that, this log 10 is 1, so it will be 4. This log 4 is nothing but it is 2 raised to power 2, right? So you can write 2 log 2 plus 4. 2 log 2 is 0.301. So you can just put the value 2 into 0.301 plus 4. You can solve the value of log of 40,000 here by yourself, right? Is that clear? Okay, perfect. Now, next question is, this question is repeatedly asked, right? Repeatedly they are asking you this question. Even in your model test papers, you will see this question repeatedly asking, right? Now, this question is based on one very simple formula, right? I'll tell you what is the formula. The electrode potential for the Daniell cell is given to us, that is 1.1 volt. Okay. This is the cell representation that is given to you. Perfect. Write overall cell reaction and calculate the standard Gibbs free. Now, whenever they are saying that you have to have a relation between standard Gibbs free energy and the electrode potential, so simple formula is delta G is equals to minus NF E naught cell, right? Now, this E naught cell is given to you. Faraday is nothing but 96500, or direct value is given to you, that is 964, precise value is given to you, right? But approximate value you can take 96500 also, but here take it as when some value is given in the question, you have to take this value only. If they don't give Faraday value, then you will write it as 96500, right? So this is also given to you. Now what is the value of n factor here? That becomes a question. Okay, so anybody in the comment section, can you tell me what is the value of n factor? Number of electrons lost and gained. Yes, Navya, I have already sent the PDF in the Telegram. You can check that, right? And this will also be provided on the Telegram channel. Now, here it is, write overall cell reaction, right? So if you, you have to write overall cell reaction as well. Okay, so firstly, I'll write the cell reaction. I know that this is 0 to plus 2. So basically, this is happening to be zinc is getting converted to Zn2 positive, right? And Cu2 positive is getting converted into Cu, right? Both are gaining and losing 2 electrons. So n factor is going to be 2 here. So I'll just put the value. Cell reaction also we have written here, right? You should also write which is solid, which is aqueous. This also you should write here, right? Okay, only then this will be a proper cell reaction. And this formula you will apply to get the value of delta G naught, right? Okay, from here you will be able to get the value of delta G naught, right? Now, let us see if they have given any value that calculate the standard Gibbs free enthalpy for the reaction. They have not given us that you should calculate it in kilojoules or joules. So, even if you calculate it till joules, that is also fine. Even if you calculate it in kilojoules, that is also fine, right? Because this is not an MCQ based question, right? So, any of this will work. But if they have specially mentioned in the question that you have to calculate this in kilojoules, then you have to calculate in kilojoules only, right? Now, next question is based on the chemical kinetics, the numerical from chemical kinetics, okay? Now, the rate of a particular reaction doubles when the temperature changes from 300 to 310. This we know that at every 10 degree rise in temperature, the rate constant will double. Calculate the energy of activation of the reaction. A very, very, very important formula. I'll just show you that formula, right? This has been frequently asked again, right? Trust me on that. You will see this formula somewhere in your exam, right? Definitely you will see this. That is log of K2 by K1 equals to EA by 2.303 R, that is gas constant, T2 minus T1 divided by T1 into T2. Now both the temperatures are given to you. This is given, this is given. They are asking you activation energy. Now here they have given us that rate constant doubles. That means K2 is equals to 2 of K1, right? So if you put the value here, this is 2 of K1. K1 will cancel. It will become log of 2, right? So log of 2 is nothing but 0.301, right? That value you should know, right? Now, activation energy you have to calculate. R value is 8.314. Put all the values here, put all the values, and you will get your answer either in joules or in kilojoules. That is totally your choice, right? It doesn't matter if they have not mentioned anything. They have just said energy you have to calculate whether in joules or kilojoules, right? Okay, understood, right? Understood, guys? Is that clear? Is that clear? Now, next question here is, now either they will ask you numerical from this particular portion, that is this formula of rate constant and activation energy. If they don't ask from here, then definitely they are going to ask you question from first order kinetics of chemical kinetics. First order kinetics is the most important thing, right? Okay. Simple formula based question will be asked to you, right? So, question is, a first order reaction is 50% completed in 2 hours. That means T half is given to us. So when T half is given to us, you can easily calculate the value of rate constant, because T half equals to 0.693 divided by K. That means K is equals to 0.693 divided by T half, right? Okay. Now, next is, what is the time required for the completion of 80% of the reaction, right? Now you have to complete 80% of the reaction, right? K is given to you, time required they are asking. So for that, what we will do, we'll directly apply this formula. This, so we have calculated the value of K. Now we will apply this formula, that is T is equals to 2 point, this is the formula of first order reaction. T is equals to 2.33 by K log of 10 initial by final. Now they are saying, the question is, ma'am, 80% they have given. So guys, very simple trick for all of you to understand the numericals, to solve the numericals. If they have given it in percentage, then you will always take initial concentration to be 100, right? And if they are saying initial is 100, 80% time required for the completion of this much, that means final concentration is going to be 100 minus 80, that is 20, because 80% reaction has been consumed, right? You are just left with 100 minus 80, that is 20, right? Now, if it is given in fraction, if let's say they have given 3 by 4th is completed, 3 by 4th is left behind, then always you will take initial concentration as 1 and final will be 1 minus x, right? Whatever is consumed, or final will be y, whatever is left behind, right? Okay, so that is a main important thing for all of you to answer things correctly, right? So here when you apply this formula, that will be initial is 100, final is 20, is left behind, right? Solve this, log of 5, right? When you will solve this, you will get your answer. Now, see one thing here, this was given in hours, okay? That means this will be in per hour. When you put it over here in this formula, that means this time will be in hours, not in minutes. Sometimes students do this mistake. They mistakenly they write it here seconds, and that's how you lose marks, right? Okay, so this is also in hours. If K is you're calculating in per hour. If already T half is given in hours. Okay, got it? Till now, any problem, students? Till now, any problem? Any problem till now? We have done the numerical part, right? Okay, till now, if you have any problem, then let me know in the comment section. Now, starting with some questions of inorganic chemistry. 1, 2, 3, 4, 5, 6, 7, 8. Right? In the recent years, it has been asked multiple times. Okay. So the question is, describe the process of preparation of potassium dichromate from the chromite ore. That is why I am saying again and again, they have asked about potassium dichromate, that is K2Cr2O7. Doesn't mean that they will ask K2Cr2O7 again in this year. It means that they might ask you KMNO4. That's why I specially pressurize you to learn the preparation steps of KMNO4 as well. Right? Now, preparatory steps of K2Cr2O7 is, it is prepared from this ore, that is chromite ore, that is FeCr2O4. Right? Now, you will get the formation of sodium chromate. From sodium chromate, you will react this in the acidic medium. This will be converted to sodium dichromate. Now, when you react this with KCl, this will be converted to potassium dichromate, right? Very simple, easy preparatory process. That is 3-step reaction it is, right? Okay, understood? 3-step preparation it is. Next is, transition metals and their compounds are used as catalyst. Give 2 reasons, right? Now from DNF block, theory based questions they repeatedly ask you, right? Now, reason why it is being used as a catalyst is variable oxidation state. presence of vacant d orbitals, that is why it can variate the oxidation states, formation of intermediate compounds, right? Between the oxidation state, you have intermediate compounds can be formed. Provides large surface area for the adsorption of the reactant. It will provide surface to absorb the reactant so that catalyst can work properly here, right? That is why transition metal elements act as a very good catalyst, right? Very, very important question. Multiple times this has been asked. That is, Cr2 positive is reducing agent, whereas Mn3 positive is oxidizing, even though both have D4 configuration. Very, very important question. Reason is, Cr2, that is, if you talk about the electronic configuration, Cr2 gets oxidized to Cr3 positive, right? Why? Because 3D3, because of half-filled subshell, it has T2G3 and EG2. Because of this kind of configuration, it is extremely stable. That is why Cr2 positive is a reducing agent. Because itself, it is getting easily converted to Cr3 positive. The oxidation number is increasing. Itself, it is getting oxidized. So, it is going to reduce something else. That is why Cr2 positive is a very good reducing agent, right? Next, they are saying Mn3 positive gets reduced to Mn2 positive, right? Mn3 positive, manganese is what? Manganese is 4s2, 4s1 3d, wait a minute, okay, 4s2 3d5, right? You lose 3 electrons here, right? That will be 3d4. Now 3d4 is not at all stable. It would want to gain 1 electron and get converted to 3d5 because it is a half-filled stable configuration, right? So extra stability due to presence of half-filled d orbital, it would want to get converted to Mn3 positive to Mn2 positive. That is the reason oxidation number is decreasing. It itself is getting reduced. It will oxidize something else, and that's how it is behaving as a very good oxidizing agent, right? Okay, now next question on your screen is very, very, very important. That is, describe the crystal field splitting in tetrahedral coordination complexes, right? So in tetrahedral coordination complexes, what will happen here? If I tell you that it will be totally opposite, 3 orbitals above and 2 orbitals below, right? Here it is dx square minus y square, this is dz square, this is dxy, this is dyz, this is dzx, right? Due to repulsion between electrons in metal d orbitals, firstly all are degenerate, right? Due to the repulsion, the electrons of ligand d orbital split into 2 sets. First set is lower energy d orbital, that is dx square minus y square and dz square. That is called Eg, right? Okay, higher energy d orbital is dxy, dyz, dzx, right? Now, next they are saying the energy of 2 Eg orbitals will decrease by 3 by 5 delta T. That means if you talk about these, this is the Berry center, right? If you're talking about this is going to decrease by 3 by 5 and this is going to, and that of 3 T2G will increase by 2 by 5. This is 2 by 5. And you should also draw the diagram in the exam, okay? Since d orbital splitting is small, only high spin, this is a very, very important concept of tetrahedral, that if you compare tetrahedral and octahedral, definitely tetrahedral is equals to 4 by 9 of octahedral, that is approximately half of octahedral. That means we can say that octahedral has more splitting, tetrahedral has less splitting. That is why they don't want to cause the pairing. That is why they are mostly high spin complexes are formed here. It is a very, very important point for your tetrahedral complexes, right? Okay. Next question. So many times this has been asked based on VBT, right? Using VBT, account for the geometry and the magnetic property of COF63 negative. Here, beta, I am giving you just one example of VBT. The compound can be changed in your exam, but the concept the steps are going to remain as it is same, right? Okay, now let us see. Firstly, tell me fluorine is a weak field ligand or a strong field ligand. I want to see that in the comment section, whether fluorine is a weak field or a strong field ligand. If you talk here, this is x minus 6 is equals to minus 3. That means x is equals to plus 3. We know that cobalt, that is 27 oxidation number. That is basically 4s and 3d. This is 27, so it is 2 and 7. Right? Okay. Now, we are saying cobalt 3 positive. That means 2 electrons will be eliminated. 1 will be eliminated from D. It will be 3d6. Here what we are about to do, this is 3d6. This is going to be 1, 2, 3, 4, 5. This is 4s. This is 3d. Now, here what we are going to do. This is a weak field ligand or strong? This is a weak field ligand, right? Okay? Yes. Now, here because it is a weak field ligand, that is going to be 1, 2, 3, 4, 5. It will not cause any pairing because weak field ligand means the splitting is very less. That means the electron does not want to jump on the next level. It would, the electrons would want to jump on the next level rather than staying on the same level. If someone is asking you that you will get pizza party on the second floor, you will definitely go there. If someone is saying that you have to go through the stairs and you have to go to 23rd floor, you will say, I'll buy pizza myself only, right? So here it is 1, 2, 3, 4, 5 and 6. That means you are left with this thing. Now, because it is 6, that means either it can be sp3d2 or it can be d2sp3, right? Here, this can be sp3d2 then, right? Because this is already occupied. So this is 1, 2, 3, 4, 5, right? So this will be sp3d2, sp3d2. Now, sp3d2 is a outer octahedral. Now, what they are asking, using VBT, magnetic property in geometry you have to tell. Geometry is outer octahedral, outer octahedral. Next is because of the unpaired electron, it is paramagnetic in nature. It is paramagnetic in nature. Third is, if number of unpaired electron is 4, mu is going to be under root n plus 2 Bohr magneton, right? Okay. Here, you don't need to put the values, calculate the under root, ma'am. Who will do that? Okay, no worries, just write it 0.9. If it is 1, 1.72, 2.83, 3.94, 4.95, 5.9, just directly write it there, right? And you will get your answer. Now, tell me one thing. If you have coordination number as 4, let's say you have coordination number as 4. If coordination number is 4, there are two chances. Either it can be sp3 or it can be dsp2. This is square planar, this is square planar, right? And this is tetrahedral, and this is tetrahedral. This only they can ask you from VBT, and that is a sure short question. It's a fixed question. Definitely they will ask you this in your exam, right? Okay, understood? Yes. GM, I think more properly who can answer this? What you want me to do? Do you want me to extract each and every D block here, right? What else is proper solution? First you tell me that, right? I don't get your proper solution because this is a proper solution only. This is sp3d2 octahedral, outer octahedral, paramagnetic. I have even calculated the magnetic moment for you, right? Okay, understood? Yes. Okay, is there any problem here? Okay, now next is from organic chemistry, right? We'll do some short questions here, right? High chances are they will ask you directly question revolving around these things, right? So first is you should definitely know what is SN1 and what is SN2 mechanism. That is a very important thing, right? SN2 mechanism with an example. Now SN2 mechanism means it is bimolecular. 2 means it is bimolecular, right? That means the rate of the reaction depends on the nucleophile as well as the reactant, the substrate, right? Second is because it is 2, so we can say it is one step, right? One step means transition state will be formed here. Transition state will be formed here, right? Now we will see the full-fledged mechanism, how this happens. If you see this here, what exactly happens here? That firstly, what will happen here? It will do the cheating, right? Cheating means the one who is not loyal. He is also attached to X, right? Let's say this is the X. He is also attached to X, but he is also inviting new nucleophile, right? I am talking to the X, but I'll also talk to the new person, right? So now here what is happening? This will attack on the carbon, right? And now this carbon, being a cheater in SN2 mechanism, it is bonded to 5 bond it is having here, where slowly and steadily it is breaking the bond with X here, right? And it is forming the bond with the new nucleophile. And this state is called transition state. When you are transiting, you are having the transition from you are bonding, breaking the bond with X, and you are making new bonds here, right? That's not a loyal person, right? So don't be like this carbon, right? So here it is, after this is the slowest step. And in the slowest step, we know that slowest step is the rate determining step. That is the reason in the slowest step you have nucleophile and as well as the substrate. That is why the rate determining step, the rate of the reaction is dependent on 2 species. That is why it is a bimolecular reaction, right? Okay. Now here what you will see in the fast step, what will happen? This will be eliminated and hence you will have the formation of this new product over here, right? Now, what you will see here, that you have the formation of inversion products, okay? SN2 mechanisms involve only one step. This attacks on electron deficient, partially broken. Further, this breaks completely to form methanol, right? That becomes your SN2 mechanism. SN1 mechanism is a loyal person. Now, tell me what a loyal person will do. What a loyal person will do? A loyal person will firstly break up, then will get attached to the new nucleophile. Same thing is done here, right? So firstly, they will break up. They will break up with which thing? Firstly, you will have any alkyl halide, right? Okay. In the slow step, firstly, what will happen? Beta, this is a one step. Some students say, ma'am, it is 2 step. No, it is in, because this transition state is not at all stable. So that is not considered as 2 step. This is 1 step only, right? Okay, this is considered as 2 step because it is 1 step. This is still more stable as compared to transition state. Then you will come to the second step. Firstly, it will break up with the halogen, right? You will have a carbocation formation. After that, from 2 sides, what we are saying, from 2 sides it can attack, right? Here it didn't have any option. It was like I only have space over here, right? I can only attack from this position, right? So it was the inversion product, right? But here what happened? It has space from both the sides, right? That is why racemic mixture is obtained. That is retention plus inversion product is involved here, right? Okay. If you want to add one more step here in the transition state, because of the steric hindrance, 1 degree is maximum, then 2 degree, then 3 degree, right? Then 2 degree, then you have 3 degree. This is the stability, how fast it will react. 1 degree, then 2 degree, then 3 degree. Here, because of the carbocation, first it is 3 degree, then 2 degree, then 1 degree. This also you can add here, right? Okay, understood? Okay, now, so like ma'am, move on. Ma'am will not move on, because if ma'am moves on, maybe that question they will ask you that what is the stability order in transition state of SN2, SN1. Then you'll say, ma'am, I wish you have not moved on. What is the Wurtz reaction? Give an example. Wurtz reaction. What is Wurtz reaction? So you have 2 alkyl halides in the presence of sodium and dry ether, because sodium is very reactive. That's why you're using dry ether here. Now what will happen? NaX will be eliminated and you will have the formation of R here. And in Wurtz reaction, you always have the formation of symmetrical alkenes. Unsymmetrical alkenes are not obtained here, right? Okay. Next is, how is phenol manufactured from Cumene process? A very, very, I would say, This is a very famous question these days. Cumene process, right? So how that is formed? First, you need to know what is cumene. So on benzene, if you have isopropyl, that is C, CH3, this is H, this is CH3. That is cumene. That is cumene, right? Now, this cumene, when you react this with oxygen, right? Okay, when you react this with oxygen, what will happen? Here, peroxide linkage will get added on and you will have the formation of COOH here, right? Peroxide linkage will be added here. After that, when you hydrolyze it in acidic medium, this compound is going to give you two products here. First is this phenol, other is this acetone, right? That's why this particular process becomes very, very important. One is phenol, other is acetone. Got it? Now, next question is Kolbe's reaction and Reamer-Teamer reaction. Very, very important naming reactions, right? Kind of similar also because both are formed from phenol only. In Kolbe's reaction, you have the formation of salicylic acid, right? And in Reamer-Teamer, you have the formation of salicylic aldehyde, right? Here, what you do, you add NaOH, you have the formation of replace H positive with Na. Then you add CO2 and H positive, you will have the formation of salicylic acid over here, right? If you talk about Reamer-Teamer reaction, here the reagent is same as carbylamine test, that is isocyanide test, right? Carbylamine test, that is for 1 degree amines, right? Okay. Why I am also talking about carbylamine here? Because they are quite similar. In carbylamine, you have RNH2, same reagents. It is converted to RNC. Here, phenol is converted to salicylic acid. The reagents are CHCl3 chloroform plus aqueous NaOH, right? Then again you fuse it with NaOH, you will have the formation of ONaCHO, and then in acidic medium this will be converted to OH, you have the formation of salicylic aldehyde. Now, if you use CCl4 here instead of CHCl3, then you will have the formation of salicylic acid, right? That's a very, very important question, right? Okay. Both ortho and para are formed here, but ortho because it is providing hydrogen bonding here, that's why this is more preferred here, right? Okay, that is a major product. Then ether formation, we have Williamson synthesis reaction, right? Which is extremely, extremely important for you, right? Explain Williamson synthesis reaction with an example, right? Okay, everybody? Okay, till now, let me see how many likes you have given to this session, right? Very good. Let's make it to 200 likes before the end of the class. Okay, let's make it to up to 200 likes. Let me see if you can do that. You can complete your challenge or not. Now here it is, explain Williamson synthesis reaction with an example. How do you prepare methoxyethane by Williamson synthesis reaction or general equation for Williamson synthesis? That means by different methods, they can ask you different questions, right? Okay. Williamson synthesis reaction is a very important naming reaction. Okay. So this is RONA, right? Rona, right? This is Roxa. We are saying Roxa, Rona. Don't cry, Roxa, right? So Rona, Roxa, right? Here what will happen? This NaX will be eliminated and you will have the formation of this unsymmetrical ethers can also be prepared here. Now they are saying prepare methoxyethane, they are asking you. Methoxyethane means that one chain will be methyl, other chain will be ethyl. So that can be prepared by this particular thing when you have CH3CH2ONA plus CH3Cl. This will be eliminated and you will have the formation of the desired product, that is the ether will be formed here. Got it? Understood? Next is explain aldol condensation with an example, with an equation by taking acetone. Aldol condensation, very important, very important naming reaction. Aldol condensation is CH3 with the help of taking the example of acetone, they are saying. This is acetone. Now, I told you one simple concept. Whenever you are doing aldol condensation, for one molecule, take C double bond O, right? For the other molecule, expand the alpha hydrogen. That is, this will be CO, this is CH3, this is CH2, and this is H. Right? This is the alpha hydrogen here. Right? This is the alpha hydrogen here. Now, can you tell me one thing, that if I am saying what I told you next, attach the carbonyl carbon with the alpha carbon, right? Attach carbonyl carbon with the alpha carbon, that will be, this is CH3, this is C. Here, when you attach this carbon with this carbon, this will be CH2, and this CH3 I have written it here. This CH3 that is linked to this carbon, I am writing it here. Now this electron will be shifted here, and this double bond O is converted to OH, because this hydrogen is shifted here, right? Rest of the things are same. This is CH2, this is CO, CH3, right? Now, after that, we know that it is also forming condensation product. That means OH will be eliminated here and H will be eliminated here. Hence, you will have the formation of this kind of product. So, this is your aldol condensation product. Okay, that is aldol condensation product. Understood or not, everybody? This is your aldol condensation product that you will form in these 3 steps. Right? Okay, very, very important reaction. Right? Okay, so we have already formed this. Next is, how does, this is basically Cannizzaro reaction. How does benzaldehyde? Benzaldehyde is what? This thing. How does benzaldehyde, I'll just draw it here. This is benzaldehyde, which does not have any alpha carbon, hydrogen. This is acetophenone. Acetophenone is double bond. This is COCH3. Okay, I'll just draw it like this. This is benzene. This is CO. This is CH3. Okay. Now, here what we are going to answer, everybody? Yes. Now, here if you see, this is the one that has alpha hydrogen, only that we can have alpha hydrogen for. So, this has alpha hydrogen, so this will be regarded as CH2 and 1 hydrogen here. Now, what I told you, just attach carbonyl carbon with the alpha hydrogen, that is this one. That is this one. Right? So, once you attach this, you will have, this is benzene, right? This is C. This double bond is converted to OH. This is CH. Here we are attaching CH2, right? Then this is CO. This is again one more benzene. Then you are doing the condensation also. So, OH is getting eliminated, H is getting eliminated, and this is the final product that you are making here. So, aldol condensation and Cannizzaro reaction are very, very extremely important for you. Right? Okay. Now, I think this is the last question here. Yes. Okay. Very important question from amines, that is, how is methanamine prepared by Hoffmann bromamide degradation reaction? So, basically what happens here, you have CONH2, and here this will be eliminated, it is converted to RNH2. Okay, so CO is directly eliminated here. So, directly what you can write here, when acetamide, that is, let's say CH3, CONH3 is reacted with Br2 and KOH, KOH is alcoholic, then this CO is vanished out and you have the formation of RNH2 that is formed in the end, and you have K2CO3 and KBr, and these are the byproducts. That is called Hoffmann bromamide degradation, because we are degrading, the carbon number is getting decreased here. Right? Okay. Yes. Is that clear to everybody? Is that clear? So guys, these were some of the questions that you will definitely see in your PU board exams, right? So I really hope so you enjoyed this, and full chemistry you are able to revise through these small sessions. And moreover, I am going to take one more lecture tomorrow, that is for 2 marks, 3 marks and 5 marks questions. I am going to take very, very important question for your practice from each chapter, right? So that is going to be very helpful for you if you really want to revise it for that revision that you need one day before the exam, right? Okay, and after that we are also going to solve a paper. I'll provide you with the paper, right now I am making that paper for you guys, right? Because a lot of research goes into making exams, making these questions for you, right? A lot of research goes into that, right? So currently I'm making that paper for you, but I want you guys to solve it yourself as well, right? Okay, guys, till then, bye-bye, see you, and I'll see you tomorrow at 12 p.m. for your 2 marks, 3 marks, and 5 marks session, right, which is going to be extremely important for your very good revision, right? And that is, you will thank me once you have given the exam, and when you will come home, you will definitely thank me for that, right? Okay, yes. Okay, then bye-bye, take care, see you all, bye-bye.